section for you. This is the question that we are working on. We are working on this question here that the question, it is given that PQRS is a parallelogram. Let us talk a bit about that. What is a parallelogram? Guys, a parallelogram is any four-sided figure. Any four-sided figure and whereby the opposite sides are parallel and equal. Right? So the opposite sides are parallel and also equal. What else do we know about a parallelogram? We do know that the diagonals, maybe I should try to write more clean. Opposite sides are parallel and equal, right? And that is a parallelogram though. The opposite sides are parallel and equal. We also do know that the diagonals will bisect each other, right? Meaning that at the center of diagonals, where diagonals intersect, it will form a midpoint. That is what is meant by a parallelogram. This is something to know as soon as you are being told that a particular figure is a parallelogram. Remember, I am your mathematical coach. You're more than welcome to ask any question or post any question. I will make a video on it. Most of the time, I do focus on the questions on previous question papers. However, if you want me to explain a concept from the beginning, I will definitely do that. We are further told that PR and QS intersecting in M, all right? B is a point on PQ such that SBA and RQA is a straight line. This is to emphasize that SBA and RQA are straight lines. Then we are further told that SB from S to B, the length of SB will be the same as the length of from B to A. Hopefully, we will use that information. We will see, right? Let me try to remove everything here. I do hope that you'll remember what we just discussed now, guys. Don't forget that SB is equal to BA in case we have to use that information. Now, let us check the first question for 4 marks. We have to prove that SP is equal to QA. How can we go on about that? SP is equal to QA. Where is SP? Here is SP on our diagram. We want to show that SQ is the same in length as QA. Right. How can we do that? Well, I like to point out the obvious first. I like to point out the obvious things whenever I am answering a question. What is that obvious thing that I'm talking about here? That SP, the question talks to SP. I know that I will have to say something about SP, right? I do know that SP in length will equal with RQ or QR. Let me write RQ. I have no reason why I write it like that, but we definitely do know that SP will equal to RQ. It is the fact that we just talked about in any given parallelogram, the opposite sides are parallel and equal. So this implies that SP is equal to RQ. We were told that PQRS is a parallelogram. So you can just write your reason, opposite sides of a path. That will be your reason. Right? Now, I definitely don't want RQ, guys. We want to show that SP is equal to something. Most of the time when you do this question, you need to link your information. Now we want to link RQ with QA. Let's go back to our diagram and find out how we can do how can we come up with an answer there. Remember, I do these questions unprepared. I tackle them as I see them. Right, I want to link RQ with QA. This is RQ, this is QA here. Now I will focus. At the moment, you should have learned what we call a midpoint theorem. You should have learned what we call a midpoint theorem. I will talk about it in a moment. I just want to highlight to you to focus on this triangle SAR. Remember, we were told that SDA and RQA are straight lines. So that means SAR is a triangle. We were also told that PQRS is a parallelogram. What can we say about that information? We definitely do know that SR will be parallel to PQ. Now, before I proceed, let me highlight the midpoint theorem for you. Midpoint theorem will teach you. Midpoint theorem, it talks to if we have a triangle A, B, C, and we have a line segment, a line joining between the triangle DE. Midpoint theorem will teach you that if it is given, or if you are able to find out, or if you are able to calculate, right? If it is given that AD is equal to DB and that AE is equal to EC. If you are able to show these properties, or if you are able to calculate these properties, that if it is given AD is equal to DB and AE is equal to EC, and maybe let me not use two lines in both sides. That will be some sort of contradictory. All right. If it is given that AD is equal to DB and AE is equal to EC, then we can draw the following conclusion in this particular instance. We can definitely draw a conclusion that says, therefore, DE will be parallel to BC. This is what we learn from midpoint theorem. We learned this from midpoint theorem, guys. Okay. I will also say something about this when I'm done with the second scenario. The second scenario is that when we are given a triangle, I'm simply drawing a similar triangle, triangle ABC, and we have the lines here joined DE. If it is given, or if you are able to calculate this, the following. If it is given that AD is equal to DB and that DE is parallel to BC, you can see the difference between the two, guys. In the first scenario, we are given that AD is equal to DB and AE is equal to EC. In the second scenario, we are given that AD is equal to DB and that DC is parallel, DE is parallel to BC. Then we can draw a conclusion that AE will equal EC. Again, the reason here will be midpoint theorem, right? And the last part of the information that I did not say for now is that in both cases, either this case or the second scenario, it doesn't matter, but in both cases, we also draw a conclusion that says, let me remove this first part here. I will write it again. All right. In both cases, we are allowed to draw a conclusion that reads BC will definitely be 2 times the length of DE. In both cases, case 1 and case 2, it doesn't really matter which one you are wishing. But in both cases, you are able to draw a conclusion that BC will be 2 times the length of DE, right? Let me write that information I had written before. I had written that SP is equal to RQ, and then we said this is opposite sides of a parallelogram, right? Now, the reason I was explaining this information here is that I want you to focus on the triangle that I highlighted. We were told that SB is equal to PA. And I just pointed out to you that since PQRS is a parallelogram, then that implies SR is parallel to PQ. Now we can clearly see we have a second scenario of our midpoint here. We are given two sides that are equal, and then we are also given another pair of sides that are parallel. We can then draw a conclusion to say that AQ or RQ, whichever you write it, guys, RQ will equal QA. Your reason will be midpoint theorem. You found out this information using your midpoint theorem. Now, how do we draw our conclusion? We want to conclude that SP is equal to QA. Notice that RQ is equal to both SP and QA. RQ is equal to both SP and QA. Then we can draw a conclusion that since RQ is equal to SP and RQ is equal to QA, then this means that SP must equal QA, guys. This is a basic geometry concept, this one here. It is that to say, if A is equal to B and B is equal to C, this implies that A must equal C, right? We have answered the first question. I will move on to second question, that is 9.2.2. But before I move on, how are the marks going to be allocated for 9.2.1? The question is 4 marks. You will be allocated a mark for statement and the reason, second statement, and then a reason. Then you get your 4 marks. Right. You don't get a mark for writing the final answer that SP is equal to QA. It was given to you. You will not get any marks for that. Now let us move on to go to 9.2.2. Again, I will erase here. Try to remember what we discussed, what we talked about. Try to keep it in your mind. Now, the second part, we want to prove that SPAQ is a parallelogram. Now, I'm going to indicate to you what needs to happen in order to prove a particular figure is a parallelogram. You basically need to know your properties of a parallelogram, guys. So if you can show the properties of a parallelogram using correct method of geometry or correct method of mathematics, then you can draw a conclusion that particular figure is a parallelogram. What do I mean by that? I do mean that if you are able to show that SP is equal to QA, let me highlight the figure that they are talking about here. They are talking about SPAQ. So this is SP, and then we go to A, all right, and then we go to Q, right, and then we go to back to S. This is the shape that we are talking about. So we want to show that particular figure is a parallelogram. So what needs to happen? You need to prove at least one property of a parallelogram from that figure. So case one here is that if we can show that SP is equal to QA and that SP is also parallel to QA, we need to, if we can show this property, we will have successfully answered the question. The second property is that if we can show that SQ is equal to PA, I want to write PA there. If we can show that SQ is equal to PA and that SQ is also parallel to PA, that is the second property, right? What else? If we can show that, let me just write them. If we can show that SQ is parallel to PA and that SP is parallel to QA, that is the third property. Another thing that if we can show that SB is equal to BA and that PB is equal to PQ, right? I will try to remember other things as I move along. Like if we can show any of these properties, if we can show any of this property, this is case 1, case 2, case 3, case 4. If we can show any of this property, then we will have proved that particular figure is a parallelogram. Now, usually I will start with what I already know. Now, I already know, this is what I already know as. This is what we already worked out. We already know that SP is equal to QA. We already worked out this part. This is proven. You can just write proven. You can just write proved in the previous question, or you can simply write proven, whichever you prefer. So we already know. This condition talks to this part. Talks to this part. Now, can we get SP to be parallel to QA? Once we achieve that that outcome, then we will have answered the question, right? I hope you are with me. Now, the question is allocated 2 marks. I will avoid to take the longer route. I will try to show you what needs to happen, right? Now, how can we show that SP is parallel to QA? We definitely do know. We definitely do know that SP is parallel to RQ. We definitely do know this information since PQ RS is a PAM. We definitely know this information. And then we were further told that RQA is a straight line. We were told this information. Now, what can we say about these two statements here? Since SP is parallel to RQ and RQA is a straight line, right? I'm saying SP here is parallel to RQ here, and that RQA is a straight line. This means we can draw a conclusion that it means SP must be parallel to QA. That's what I'm trying to say, guys. But since this question is 2 marks, I would like to think that, you know what, let me just leave it there. Just show your workings, I show your calculations. Let me leave it at that. Let me not teach you how to write half answers. Right. Let me not teach you how to write half answers. Now, what have we done here? We have successfully showed, we have shown that SP is equal to QA. We have also shown that SP is parallel to QA. This is our case 1. We can then draw a conclusion that therefore SPAQ is a parallelogram. I'll just write PAM. SPAQ is a parallelogram. Which property did we use, guys? The property that we have used here, we've used opposite sides of a PAM. What else did we use? We also used, we used opposite sides of a parallelogram are equal. Opposite sides of a PAM are equal, and that also opposite sides are parallel. That's what we have used, yes. You can just write opposite sides of PAM. I think that will be accepted. Now we have proved that SPAQ is a parallelogram for 2 marks. How would I allocate this marks? I would give 1 mark for both statement and the reason, for both statement and the reason, and the final mark for reason. Concluding that why are you concluding that SPAQ is a parallelogram? The reason that you will provide there, I will also award a mark for it, right? Hopefully we are on the same page. Let's go to question 9.2.3, whereby we require to prove that AR is 4 times MB. Let me remove, guys, as I've already said, I hope you do remember the things that we talked about, because I may need to redraw another lines so that I demonstrate the things that I talk about. Now we want to show that AR is 4 times the length of MP. Where is AR? This is AR here. And then where is MP? This is MP. Okay. Okay. It's 4 marks. Okay. Now, how can we work out that part? You will remember when we started, we talked about midpoint theorem. I tried to explain midpoint theorem to you, that whenever we have AD equal DB and AE equal to EC, then we can draw a conclusion that DE is parallel to BC and that BC is 2 times DE. Midpoint theorem. I will attempt to use this knowledge here. Let's see how that knowledge applies in our diagram. How will that knowledge apply? Let me construct a triangle that you are able to see. A triangle that you are able to see. I do hope that you see the triangle that I'm constructing. Triangle PQR. Hopefully you do see that triangle. What can we say about that triangle? We can definitely point out. That PM is equal to MR. Yeah, we can definitely say that. Remember, we were told that PQRS is a parallelogram, right? So that means PM is equal to MR. Those are the diagonals. Diagonals of a parallelogram bisect. Diagonals bisect. What else can I point out here? Can I point out that PP is equal to EQ? Can I point out that? Definitely. Definitely, I can point out that. Because we just proved, remember, we just proved that SPAQ is a parallelogram. We just proved that SPAQ is a parallelogram. We just proved this part here. So you can clearly see at point B is where the diagonals of that parallelogram intersect. So the reason will be diagonals bisect. Now, what situation do I have here? What situation do I have? I will reconstruct that information. Don't worry. What situation do I have? We have, which triangle is this? Triangle P, and then we go to PQR. This is the triangle that I was focusing on. And then I had constructed MP because I want to find MP. Now, let's put this information on our diagram. When we put the information on our diagram, we have that PM is equal to MR, and that PB is equal to EQ. We learned in midpoint theorem, if PM is equal to MR, if PM is equal to MR and PB is equal to PQ, then we can draw a conclusion. This implies that MP must be parallel to RQ. So you can write your reason converse midpoint theorem, right? Or you can just write midpoint theorem as if you are not sure, right? Now, knowing that we have a midpoint theorem here, remember, we are allowed to write this statement. We are allowed to say QR, the length of QR will be 2 times the length of MP. That's midpoint, guys. That's midpoint theorem, the one that we are dealing with right now. We are allowed to say that. But however, we do see in our question, we have AR is equal to 4 MB. We don't have what? We don't have QR. So it means we need to deal with this QR. We need to express QR in terms of AR. Can we do that? Let's find out on our diagram. We need to express QR in terms of AR here, the longer side, right? Remember in the previous question, we did show up. We definitely show up. We have shown, guys, in previous question that QR or RQ is equal to QA. We definitely showed this part, guys. We showed it without any doubt. Let me write QR for simplicity. QR. We definitely showed this part on our previous question. What does this allow us to do? It allows us to reach a conclusion that QR will be half AR. Let me quickly show you the mathematics behind it. Remember that the length of QR plus the length of QA will give us the total length of AR. This is to say the length of QR, this part here, plus this part here will give us the total length, that is AR. However, QA is equal to QR. We have shown that in our first question. So I will simply replace QA with QR is equal to AR. What will remain here? 2 QR when we collect the like terms is equal to AR, right? Now what happens when I divide both sides by 2? I will remain with QR is equal to half the length of AR, which is what we are talking about now. This one you definitely you really don't have to show this a lot of algebra. You can just point out to the marker that QR will be half AR so that you get a mark. You don't need a reason for this license. It's the mathematics that you did in grade 3. Now, what do we have now? Now, I am going to replace QR with half AR to this statement. Right. I am going to replace it there. So in place of QR, I'm going to write half AR is equal to 2 MB. Now I do have my AR, I do have my MB. The question they wanted us to express to prove that AR is equal to 4 MB. So in simple sense, we need to make AR subject of our equation. How do we do that? We need to make AR subject of the equation. From this equation, I can multiply both sides by 2 here, right? When we multiply both sides by 2, this 2 will cancel the 2. We are going to remain with AR is equal to this 2 will multiply this 2. We will get 4 MB. We are done. The last step will not be a mark because it was given to you guys. We have answered the question of Euclidean grade 10. I think it was taken from 2016 Gauteng November paper, if I remember correctly. I do hope that you enjoyed the video. Please subscribe, guys. Comment with your question. Send me a picture that you would like me to explain the answers. Or any topic that you need assistance on, I will definitely help you. If you want to join my online classes, you're more than welcome to let me know. I will definitely create those online classes and you will be part of them. I handle mathematics from grade 8. From grade 10 to 12. I don't deal with grade 8 and 9 just yet. So basically grade 10 to 12. And thank you for watching, guys. Have a lovely day.